Well, I wrote this song for the Christian booth. I want to teach kids the Christian truth. If you want to reach them homies on the street, then you gotta do a bopping that hip hop beat. So I gave my sermon an educational kick. My rhymes are fly and my beats are sick. My crew is big and it keeps getting bigger. That's 'cause science is my... Okay, so welcome again. Been a while since I did anything. So basically I've been studying certain things that we may have known in our past about the numerals that you can find on Eric Larson's channel, duodecimal division, that we may not know anymore. And basically I got all the symbols here based off of the sort of ideographic inscriptions. You can see the angle there, and then it goes in a circle for the 3 and then the 4, and that's where I'm actually kind of off. I kind of have started off there, but I'm going to go ahead and write all the other symbols: the 5, the 6, the 7, the 8, which, by the way, it's kind of, if I wanted to make the geometric shape, I mean, technically you would do like this, a figure 8, but that's kind of that. And then we got 9, and then for the base 12 we got dec, and we got L. And so this does have a lot to do with the square root radii. Like, for example, and I actually just recently made a pretty good copy of Larson's diagram. There's more to it up here, and as you can see, I got the square root radii written down to explain where a lot of these ideas and stuff came from. But for example, like the number 1 I have here, where it lines up perfectly with the first length of 1 there. It's related to the square root radius of 1, and it's also aligned with the first 1 section there. I also have 2, which is lined up with the square root radius of 2, and it has what he calls the, if anyone can explain this, the square root length of 2. I guess the reason why that would be the square root of 2 is because it goes from one side to the other. That makes sense. And then it goes down like this, a length of 2 also. For the 3, I got a little bit more complexity stuff going on, because what I got is the square root radius of 3 also involves the 2 duodecagons that I have here, which are part of the seed of life diagram. And I got the point here, which, in case you don't realize, I think that's like a 45-degree angle. I'm not really 100% sure, but it goes all the way around 180 degrees, right? So it goes around 180 degrees, which I think in base 12 would be 1 grow 3 do degrees or something like that. And you have the there's a certain length that if I think I got it upside down because it's This is not perfect. It's not a perfect diagram, but it does get the job done if done properly. If you get it in the right area, you can see it starts right there, 3 blocks in, and then it goes a length of 1, so that's 9 in all, because, you know, 3 plus 9 is 12, so that's 9 in all, plus 1 on the positive side. And then over here, you know, there's like a negative, it's like negative 1.3, which is what I got there. But altogether, it's a length of 3. Altogether, that whole thing is a length of 3. And it's the square root of 3. Okay. 1 grow, 3 dough degrees across. You know, and it's just an example. These are just a few examples of this. And an interesting thing about these number forms that I've also noticed is not only do they align with these things here, but you know that insane guy, Alan Horvath, well, he kind of has a little bit of a point. And I'm going to explain what that point is in the next video, because I really don't have much time. But this Odeote language, which is, in my opinion, is like a mixture between the Canaanite language and Aramaic. It's like Aramaic / Canaanite language that actually, it's very possible that when they picked those letter forms, they not only were trying to make a language, but they possibly were also trying to align them with geometric principles, as silly as that might seem. And I'm going to explain why that makes sense in the next video.